Hello, my name is Chris Maple, a member of the team GT Sons of Andreas, along with James Westbrooks, Nick Randall, and Andreas Ward, and this is our presentation on the planning report for the final design project. In true spirit of classic British comedy, Terry Gilliam's 1975 film, Monty Python and the Holy Grail, is this year's theme for the Emmy 2110 final project. Iconic scenes as seen before you including King Arthur's famous battle with the Black Knight, the uncasing of the holy hand grenades of Antioch, and the shrubbery debate with the Knights Who Say Ni have been transformed into the ultimate mechanical engineering design competition. Here's a layout of the competition. Teams will construct machines to be placed on the combat arena and will be pitted against each other, trying to complete tasks inspired from scenes in the movie. The tasks include defeating the Black Knight or removing the black dog bone seen in the figure from the team's zone, collecting shrubbery or pulling in tennis balls that line the respective zones, delivering the holy hand grenades of Antioch, or placing ping pong balls inside the rotating cylinder that is the Beast Slayer, and ultimately retrieving the Holy Grail. Now perhaps it would be easy if the machines only had to worry about one task, but that brings us to the first problem of multifunctionality. Machines have 4 unique tasks to perform, and accomplishing them all in a swift manner is certainly a challenge. This forces the proper allocation of resources and time per task, which means major prioritization. In addition, competition adds a dimension of difficulty as design must consider interaction with other machines, whether that be flinging arms or rogue projectiles, as it is readily known from past competitions that chaos can break out in the combat arena. Finally, restrictions on the size of the machine and limited power resources would make things challenging, not to mention the limited time as the final competition is only 3 weeks away. Of course, the overarching goal is to create the winning robot for the competition on November 11th, which will be done through capturing the points as seen in the table before you. Now, although the table outlines every point possible from defeating the Black Knight to retrieving the Holy Grail, we wanted to share a snippet of our prioritization of tasks as defined in the planning report. From our house of quality, 3 of the most important customer requirements were reliability, robustness, and easy setup procedure. Easy setup procedure is absolutely necessary, as the machine has to be boxed, placed, and prepped on the platform, and activated in just 3 minutes. In addition, it is crucial for the machine to be robust so that it withstands fatigue both during rounds and through the length of the competition. Finally, reliability is essential, as the machine needs to perform the same way every time. When taking the results from these customer needs and applying them to the 4 tasks, we found delivering the hand grenades to the Beast Slayer and capturing the shrubbery to provide the maximum potential for points. For instance, successfully delivering a hand grenade to each of the 4 zones, as shown in the diagram, with effective escape from the blast zone, secures 54 points every round. Collecting shrubbery may not be as reliable because the other teams can interfere, but the sheer weighting of the points at 7 per shrub makes collecting them an important task. Of course, we are not saying that retrieving the Holy Grail and defeating the Black Knight are not important. Rather, we have determined that the trade-off shown that we could focus our resources and time on other tasks and work secondarily to defeat the Black Knight and retrieve the Holy Grail. Looking at the specification list, one can see where the specific engineering requirements fall in terms of each task in addition to general requirements under the categories of cost, safety, and maintenance. For example, with regards to the general requirements, height of falling objects is limited to 18 inches to provide safety for everyone around the machine. Perhaps more importantly, specific measurements are recorded in terms of each task. For example, the length of the shrubbery extension arm needs to be 38 inches. Understanding these specific values and implementing them into design will help us key in on important tasks and create a more successful robot. Continuing with this early design phase, the morphological chart seen before you was created in order to better outline how the team would use the specifications and put them into a working design. All 4 subsystems are broken down further and show different mechanisms that will lead to multiple designs for the CAD phase. For example, in terms of deploying grenades, which has potential for a large amount total, the machine could roll the ping pong balls down an arm, launch them, or use a rotatable fixture. In the end, the more options the better, as testing will lead to the most effective machine. In order to accomplish all these tasks, planning tools like the ones seen before you were produced in order to keep the progress of the machine constantly moving forward. The Gantt chart outlines the weeks ahead and keys on both the importance to focus on the individual tasks, as well as continuing to understand the problem and develop concepts. The job responsibility matrix separated the tasks by speciality and applied them to the group member who best fit that category. Utilizing all of these tools throughout this report gives the team a great base for the future and hopefully is a step towards reaching our ultimate goal on November 11th. Thanks for watching, and we look forward to checking in with you next week.